Okay, any questions before I get going? Yeah.
What's the color in the diagram?
I'm sorry?
What's the color for the diagram?
Oh, for the hands, they have different colors. The outer one, if you just look at the picture, one of them is reddish and the other is purplish. Here, I have it still here from last time. See this one here? It's purple, and this one is red. I just took those colors from the Wikipedia thing. So here's purple, red. You see that? So look at it at home, and you can take a color dropper. You see, but you can just use color.purple and color.red for the color. Yeah.
Does stopwatch draw the line or does dial?
Oh, dial draws everything. So stopwatch doesn't draw anything. All stopwatch does is it pulls dial twice. Yeah.
Isn't dial is their icon thing, not the movable shape?
Yes. That's what I said. So you're gonna have to do it like that.
But how do you move with your handle using icon?
I get it. What are you moving?
You need to be movable shape to move the game.
Okay, I think I know. I know what you mean. So when you so the dial is used for the drawing, right? So the stopwatch has two instances of dial, and then it draws both of them. And how does it draw them? No. It just calls. So let's think backwards from the stopwatch. The stopwatch has what methods? We know what methods it has because we know what interface it must implement.
Draw.
It has draw and move. Okay, so let's look at draw of the stopwatch. So what is draw going to do? It has to draw both of the dials, and so it has two dials. And so it should be easy enough to draw them because the dials themselves have what method? They have a method called paint icon. So that means that draw can call paint icon. Now what does paint icon need? It needs a component, a graphics, an X and a Y. So what should we pass for the component? No, yes, because mercifully you're in full control of this because you have or you will have implemented the paint component was paint icon method, the paint icon method of the dial, and so you're not using the component. The component is just passed there because some icons maybe want to know what component they're being drawn over so they could adjust their color or some such thing. We will do no such thing. So passing null is perfectly safe. For the graphics, well, we have in the call to draw, we have a graphics 2D. That is a graphics. You can pass it. And the X and the Y, well, I would imagine that for the bigger one, you're just going to pass 0, 0. And for the smaller one, well, you have to figure out. It's going to have to be this top left corner. And how do you know what that top left corner is? Let me now see if I can use my here it's paint board thing out here. So what? Oh, paint. So here's the outer one. I guess I should have drawn a square. Imagine it might do a square. And here's the inner one. Do we know how big each of them are? You're given the size of the outer one, right? So this is what, 600 or whatever. So you get You're given that size, and make sure that you can handle whatever size comes in. The grader will have some test case where the size is 600, another one where the size is like 40 or something. And so it has to, well, 40 might be too small to see anything, right? But the grader will try two sizes to make sure that you take the size. So the smaller one, you just have to make somewhat smaller. And actually, the way I have it is probably wrong. It should be moved up a little bit. But you have to center it horizontally and vertically. Well, to center it horizontally, that's easy enough. You know the big size here. You know the small size here. So you know that the difference of B size is B minus S is the sum of these two. So you divide by 2, and then you can figure out what this size is. The vertical one, I fudged it a little bit so that it looked nice. So I took the difference divided by 3 or 3.5 or something. I don't remember. And that one, you don't have to make it pixel by pixel match. It just has to look right when the grader looks at it. So that's the draw thing. Now, when drawing these dials here, the dial has an angle for this thing, right? And so you just whatever the angle is, you're just going to have to draw it that way. How do you draw something at an angle? Like how do you figure out? This point is easy enough to figure out. Right, this one here is just whatever the center of the dial is, offset by something. How do you figure out the point up here? Yeah. So what's the magic functions that you need? Yeah, so you need to figure out the cosine and the sine, right? So this here is the cosine of the angle. This here is the sine of the angle multiplied by the length of the thing. So that's why they taught you trigonometry in high school, so that you can do this thing. Okay. I read this story a while ago that some company in Michigan was looking for welders. But nowadays, to be a welder, you don't just hold your torch at some piece of metal, but you have to be able to program the numerically controlled welding equipment. They couldn't find welders because there weren't enough people who knew both welding and trig. So that limited their job search. So I thought was interesting. So as programmers, we do need to know our sines and cosines. So you just figure that out. Also, all of these lines here, you have to know to get the right positions, you have to do your cosine and sine thing. So the cosine sine tells you on which angle to draw this, and then you scale that by. I kind of dimly remember that I used. I said, okay, this is 1.0, this is maybe 0.9, and this is maybe 0.8 or something, and I tried out a couple of things until it looked okay. Yeah, so if you've never done this in your life, you have a couple of hours of heartache in front of you. The secret weapon is to kind of draw it out and figure out, how would you do this computation by hand. One thing that helped me out, just in terms of programming tedium, was that if you look at this bar over here, you can't tell, but I just actually drew the small one and then I drew the middle one over it because it didn't seem to be worth the logic to skip the small one. Saved me a few lines of code. Okay, where was I? Okay, so again, dial implements icon and it just produces this paint icon method to produce a dial that's located anywhere in the world. The angle is put in, and it'll just draw the hand at the given angle. So there's no way to move the dial except by calling set angle. If you were to call set angle, then the thing would move. Now, who calls set angle? So the stopwatch will call set angle. So whenever the stopwatch is called, whenever its move method is called, the stopwatch doesn't actually move across the screen, but instead, stopwatch figures out what angles it should set for both of the hands, and then it calls set angle on both dials. The other thing that it needs to do is it then, someone needs to call repaint, but that's already done by the outer call. Never mind, the repaint will happen. How does the stopwatch know what to set the angle to? Yeah, so the stopwatch should call instant.now, and it should have also called instant.now when the stopwatch was started. Then you can take the difference between two instants. I don't remember if I gave you hints for that, or you can look back into when we did this in chapter 3. Yeah, chapter 3. And so then you get a duration. You convert that to nanoseconds. That is way too large to deal with. So I think I instantly converted it to milliseconds. And then when you have an angle in milliseconds, then you just need to start converting to seconds or minutes, and just use the fact that I think the way I said it is 0 is on the top. That makes your life a little bit easier. And then you just need to figure out this one here, the minute one, for example. In 60 minutes it moves 360 degrees, so that means every minute it moves whatever 300. Whatever it is, you do the math, and that way you can scale it. And the same thing is true for the other one. So that's just scaling the angle. It's easier to do than just explain. So be sure that you work through the algebra and the trig. It's not particularly difficult, but it's tedious maybe if you've not done this before. Similar with the positioning of these numbers. So the way that I've done it is that the midpoint of this square, or rectangle, which is easy enough to figure out, right? You have the top left corner, you have the width and the height. I want the midpoint of this to be on a line from the center that has the correct angle. You know what those angles are, right? This one here is 0, this one here is 270 degrees, and this one is 305 degrees. And so I want this point to be from here 305 degrees. I use the sine and cosine thing, and then times, say, 0.7. So that it's kind of not quite at 1.0, but a little further inwards. And then you need to subtract half of the width, half of the height. That gives you the top left corner, and then you can draw. Other questions?
How do you get the size again?
Which size?
Your numbers?
Of this thing here? Well, if you follow, there's two ways you can do it. My original idea was that you just follow the same strategy that I used in that multi-line text class that I advertised for you to look at. And the strategy is you make a J label. You make a J label, put in 50. You set the font to something largest, and you kind of need to make it somewhat proportional. I better check that I did that one right. It needs to be somewhat proportional to the total size. So don't just use small, medium, large, because if the size gets to be quite small, I don't think that's really going to work. So pick some reasonable size for the font, and when you have a J label, you can ask it, get bounds, and you get the size. So it's easy enough to find the size of a label, and that's why I recommend that you use a J label. There's another way that you can do it, is you can, but it's not described in the book, you'd have to find that elsewhere. There's a way that you can get what's called the string bounds. You can ask the graphics context would be the bounds of the string. But I think that was harder. The only tedious thing about, or not tedious, the only confusing thing about drawing a J-label is I want to draw the J-label at this X and Y. And for some reason that I've never quite understood, even though I've been doing this for many years, you would think I should be able to call what is it, set position on the label, and then just paint it, and it doesn't work. And I don't understand. Instead, what does work is that you call, and you'll find that code in that multi-line texting. You call translate on the graphics context to change the coordinate system, then you draw it at position 0, and then you call translate again to undo that change. And then it'll draw it at the right spot. It works. I mean, any graphics system has these idiosyncrasies, and so just live with that part. So that's what I thought you were going to do. Someone suggested, and that may work, I haven't thought it through, is to actually take the multi-line text class, hook, line, and sinker, and take the whole thing. I don't know, give it a try if it works. You may have to mess with it a little bit to adjust the font size, because right now, as someone pointed out, it only has 3 sizes. But yeah,
You can do that.
yeah, if you wanted to do that, go ahead. It's uncharted territory to me, but you've got to be able to beat it to submission. I don't see why not. Okay, so feel free to either take the code out of it or to just take the whole thing, whatever you prefer. Same thing with the arrow. So what my thought was, you would just take out that code that makes that general path. And I actually, I couldn't remember how to do the general path thing, so I just copied those lines of code, and I computed the coordinates of, the arrow is tedious because you have like a point here, you have a point here, you have a point here. And I found it easier to recompute it by hand rather than trying to understand that class and figure out how to repurpose it. But if you want to do it the other way, that's fine. So all of that code is yours to do with whatever you want, and you don't even, just tell where it came from. I mean, that's good practice. But it's totally out there for you to be inspired. Okay, other questions about this one? Yeah. Is what? Well, what the grader will do is you'll run a script to compile it, so it better compile correctly, and then he's going to look at it, yes. So he's going to probably run 2 or 3 scripts, or maybe one script that puts like a whole bunch of them up on one screen, so that he only has to look at one thing per student. I don't get it. But yes, then basically he's going to look at it and see that, maybe run it for a minute. Maybe, if he's smart, what he would do is he would write a script that runs it for a minute or so, takes the screen capture, and then all he has to do is look at the screen captures. I'll suggest that.
How do you create a label in your Java class?
How do I print the label?
Yeah.
That's what I say. Look up the code. Well, let me find the code so you all know how to do that. Okay. I need to figure out how to undo this. Violet. With it. Okay, so I'm going to right click on it, save link as. Why am I not clicking on it? Oh, everyone else is also horrified at the suggestion. Why am I not clicking on it? You have no idea what it will do when you click on it. Anything could happen. I don't actually have any idea what happens. This type of file. Okay, so here it did download, but don't ever click on any link like this, right? My mom clicks on links, and I keep telling her not to. Okay, so fortunately it did download. It could happen that it just starts. If for whatever reason your computer was set up that .jar was associated with running Java, some computers are, then it would just start the app. Like with Windows, when you click on a zip file, you get it in Windows confusing zip viewer instead of downloading it. So it's always a good idea to right click. All right, so here we have it in downloads. So do we have unzip on the Mac? We do. Okay, now it's not so great to just unzip it because I don't know what's inside. And I don't know how to do that with unzip, but if you say jar TV F and then a file name, what was it? Violet. Then you get a listing of what's inside. I wanted to know if there was a subdirectory in there, and there isn't. So let me make one. I meant whatever the multi-line, whatever it's called. I can't remember. Someone corrected me, so whoever corrected me, I'm sure was right. All right. So as it happens, the code is here munged right in together with the classes. That's fine. So let's look at them under Eclipse. New Java project. Never use the default location. Violet. That's good. Okay. And which one did we want? Multi-line string. Okay, here it is. Text, justification, size, set label text. Get bounds, draw. Okay, so here's how to draw the label. And so you can, that's why I say you might not just want to schlep the whole thing with you, but it's just easy enough to see how the drawing works. You call, I have this label. You get its top left coordinates. You translate by that. That just changes the coordinate system of the graphics context so that one becomes the new origin. Then you paint the label. That's now going to paint it at the x and y coordinate, and then you translate it back so that the rest of the drawing doesn't get messed up. That's how you can paint the label.
And so we would use that in our new JLabel, whatever the object is.
Yeah, this label is you can just make a label. You put in the number whatever 0, 5, 10, 15, and so on. You set the font.
Well, I mean, multi-stream would an object of multi-line stream be? Could you stick that into a JLabel new?
No. If you wanted to use the multi-line string thing, I think you could. Like I said, I haven't tried it. Then you would have to use this draw method. You have a G2, and what the heck is this R? I guess this is where you want to put it in.
So, that would have to be the.
I don't know if that's any easier.
Yeah, because you'd have to.
You can do it. I'm sure you can do it, but
change a lot of stuff.
Yeah, I haven't really thought this through. My major hesitation is the font size. That I don't think that this thing has a thing to set the font size, and you do. But let's see, this one took the font out of the. I don't know, maybe this works because this one here apparently takes the font out of G2. I think it's more complicated. So I wouldn't do it. The more I think about it, I think you should just rip out the code that you need. Other questions? Oh, someone wanted to know how to run Textile. So, let's do that before we move to the lecture. I need to download it. I don't have it on this machine. So, yes, I will demo it. You definitely want to run Checkstyle because that's the grader is going to run Checkstyle again. I want to get everyone into the habit of just doing that, and it's not worth arguing with it. It's just a tool, but everyone uses it, and so you might as well. So let's see where we get it from. Okay, download. Download. Okay, from the source for download page. I think that's what I did. Okay, so we only need the binary. We're not going to compile it. Yeah. All right, here we have it. And now what's the magic command? I also need this configuration file with tar. I downloaded the tar file, and then I typed tar. It's a standard Unix Linux command. Yeah. And you don't actually need the Z anymore. So tar xvf. It's just that my fingers know the Z. Yes. Yeah. The only thing is, but before doing that, what you want to do is make sure that it has a subdirectory in it. So then you want to do a tar tvf first to list what's inside, and then you can see it has a check style 712 directory. Because if you don't do that, and if you have a large tar file or a large zip file, it just messes up your current directory, and that's no fun. But I remember doing that a few days ago, so it wasn't a problem. All right, now so we also need this XML file here. So right click, save as. Okay, and now what was the magic command? Okay, Java. Long command. Okay, now in my case, I just put it into the home directory. And now I need a path to this one here. So let's try Dropbox. Oh, I see. Now we're running into some nastiness that I can't use squiggle here. What is it in Mac? It's users? Oh, because I downloaded Checkstyle 1712. Time has passed me by. So, so you need to adjust that number because apparently that has changed the version. And now it says there's a whole bunch of things missing. I just copied and pasted the command from here.
Oh.
I wouldn't remember how to run it. But that's the command. It's just like running JUnit. So you just
And then you have to give it directly
the path to the file.
you run one file at a time.
It can run multiple files, I'm sure. I could just try to run start Java, and I think it'll work. Yeah. So go ahead and run it on your code, and that way you'll know what the grader runs. Or if you like to live on the edge, don't do it and have the grader do it. If someone can tell me how to run it from inside Eclipse, that would be great. There's got to be an Eclipse plugin. Normally, the way that one encounters it, though, is that, we're unfortunately not going to get to that point in this course, but normally in a project, when anyone checks something in, that triggers an automatic rebuild of a project, and then you get a report. And if there's a bunch of annoying checkstyle errors, then other people are going to hate you, and then you fix it really quickly. Because the expectation is that the build report comes out squeaky clean. So that's what's called a continuous integration service, and it's very, very common on group projects. So the idea is that as soon as someone checks in more new code, that then Git will tell the continuous integration server to just rebuild the project, run all the tests automatically, and then someone gets an email if the tests fail. So that's why one gets into the discipline of just with these trivial things like putting in these comments. It's so much easier to put in the comment than to argue whether it should go in there or not. And in a group project, it is kind of important that you can rely that these comments are there. All right, so let's finally get on with the lecture. So we're going to talk about what probably is the most important and interesting concept in this course, the concept of patterns. So let's back up a little bit to motivate why one cares about it and look at something that you know from your data structures class. So when you have a linked list in Java and you want to look at the elements of the linked list, you use this iterator thing. You ask to tell the list, hey, give me a list iterator, and then you keep on asking has next, and while has next is true, then the iterator will give you the next element from the linked list. And that way you can go through the linked list one item at a time. That's what they tell you in any Java-based CS2 class. And why do they do it like that? Why do they use these iterators? And actually, the other thing that you always see when you have a CS2, you learn how to do these linked lists by hand. Right? They teach you how to run, how you have a node, and the node has a pointer to the next node, and another one. And then you must have surely had an exercise that said, write a program that takes a linked list and without using iterators or anything, does something with these nodes, like reverses them all or some other thing. Removes one. You must have had some programming like this. And you will remember. Why does one remember? Well, because it's almost impossible to get it right. I mean, these things are really tedious. And you make one wrong move, and your entire linked list is damaged. This is bad in Java. Did anyone do data structures in C++? What happens in C++ when you write any such program? You give a bunch of students, or you give me, say, reverse all of the links in the linked list. Meaning, make this one go backwards and so on, without using an iterator, really by hand, with the nodes. I mean, you're going to mess something up and the program will crash with the port. I mean, it's just overwhelmingly likely. It's so hard to get these things right the first time. And in Java, you probably get somewhere a null pointer exception or something, and it takes a while, and eventually you get it right. But it's hard to do, it's error prone, and so it's not an API that one would ever want to use. Also, it exposes the implementation. There's more than one way of implementing a linked list. If you've taken data structures from an old style professor, you might have learned how to implement singly linked lists, doubly linked lists with a header node, linked lists with a dummy node. And there's also circular linked lists. There's all sorts of different ways on how you can implement them. Nowadays, no one really cares anymore because you just use the standard implementation from whatever your library gives you. But in the olden days, people did care, and it still is there in quite a few of the books. So you don't want to expose the implementation when you give an object-oriented view of a linked list. So that's where the iterators come in, and they kind of do a reasonable job. And the reason we need iterators is that linked lists are these weirdo things. When you have a queue, there's only two positions, the front and the back, where you can insert and remove something. When you have an array, you can have integer indexes, and you can get all of the elements with an integer index. But with a linked list, you can't use integer indexes. That would be way too slow. And so you need some other way of specifying a position in a linked list. And that's what the iterators give us. There's actually another thing that you once in a while see in an older style library where they said, well, you want a position, I'll give you a position. And so they made a linked list as a thing that has a cursor. You see that elsewhere if you work with random access files, you have the same kind of thing where you have a cursor position. And then you have methods that reset the cursor to the left, that make it go one step forward, that remove or replace or look up the element under the cursor. And that works fine. There's only one problem with using cursors for linked lists as an API, and that is a linked list can only have one cursor if it's part of the API. So you can think of an iterator, because when I'm saying cursor, the cursor would be internal to the linked list, it would be part of the list, and then there's only one. But whereas you might want to have be able to go through a linked list, one iterator from the front, one from the back. So the advantage of an iterator is you can attach as many iterators as you like to a linked list. So over time, as people tried these various things of manipulating linked lists with the raw links, with a cursor, with iterators, they figured out the iterator is the way to go. And every library that you see nowadays that gives you linked lists, whether it's in C++ or in Java, they give you an iterator. In C++, if you take a standard list, there is an iterator for it, just like in Java. They work pretty much the same way. So that was the idea. So the idea here is that we learn things by having done it wrong or not optimally for some number of times and having done it right, and by comparing and contrasting. And so everyone who's done data structures has learned iterators are the ticket if you need to iterate through a linked list, or if you need to visit the elements of a linked list. And so this idea of saying you have learned from experience is something that would be nice to codify. And maybe 20 years ago, some computer scientists got into this in a systematic way, and they stole the idea from an architect, this fellow Christopher Alexander, who was an architecture professor in Berkeley, I think. He wrote a very nice book about architectural design patterns, and it has hundreds of patterns in there that would teach his students how to make good architectural design. And I'll just give you an example. So there is a pattern called short passages. And so here is something that's obviously not a short passage. And it's something that we as humans do not like. It's not enjoyable to go through this kind of long, forbidding-looking corridor. And so Alexander, this architect, came up with this pattern. And so in the context, he goes on for a paragraph or so, and he says, long sterile corridors set the scene for everything bad about modern architecture. And there's more description in it. So he gives a context as to why one might want to use this design pattern. And then he has this problem description where he says, what are the problems that we want to solve? So he has this depressing picture. He talks about lighting and furniture, and then he quotes some research that patients in hospitals get more anxious when they are in these long corridors, and some more research that suggests that corridors over 50 feet are considered uncomfortable. So he has like a few paragraphs of all of that problem description. And so now we know the problem. What we, of course, really want to know is the solution. And so he has that's the solution where he says, keep passages short, duh. But, I mean, how do you do that? And so then he says, make them as much as you can like a room. And so that then he has this picture here where he says, make them like a room, put some furniture there, and give them plenty of light. And then later on he talks about, you're better off having a room-like passage like this than corner off and have another room-like passage instead of having one long, thin thing. And so he gives a solution. Now an architect can remember and say, I don't want to do that long passage, it looks bad. Instead, I'm going to use like corners and furniture and light to solve this. And when people talk about it, they actually know the name of this pattern, and they say, hey, short passages. And then they go to the drawing board and fix that. And so we can do the same thing in the design of software. So if there are things that have been proven to be good ideas, then we can try to write them down as patterns. Writing down a pattern is not the easiest thing in the world. So right now we're just going to be learning to follow a pattern, and later we'll think about what it would take to actually come up with our own. But so let's try to see how the iterator pattern would be described and how we could follow it. So in the context of the iterator pattern, and by the way, all of these patterns that are in this book are taken from a famous book called, it'll come back to me in a minute. Maybe just design pattern. It's quoted in the textbook. And that book is kind of worth reading, and it gives all of these patterns in quite a bit of detail with historical context, with some sample code in C++ and Smalltalk, which maybe these days is no longer so helpful. So I'm trying to cut down on the verbiage here as much as possible. But nevertheless, they will sound somewhat abstract. So in the start off, he was saying an aggregate object contains element objects. This is usually where I lose people. What the heck is an aggregate object? And so it's really helpful when you read through a pattern, and that's probably the key insight of the textbook. When you read through a pattern, you want to have a concrete example in your head, a representative concrete example, because otherwise it's just too abstract. So what is the example that we have in our head for the iterator pattern? The linked list things, yes. So we have a linked list. So the aggregate object here, think the linked list, contains element objects. The elements of the linked list. Clients need access to the element object. Who would clients be? Yeah, programmers who need to work with that linked list. The aggregate object, that's the linked list, should not expose its internal structure. Well, it really shouldn't, right? It should be that's what object-oriented programming is all about. Multiple clients may want independent access. That means client 1 may want to visit the list, client 2 may want to visit the list, and those visits should not interfere with each other. So that's the context in which this pattern applies. Now that's just for the linked list. We'll later see that one could maybe think of other contexts in which this pattern applies. Well, you'll have it. I mean, it's not just for any. A linked list is really just one example. Like if you want to visit the elements of a set, you have the same thing. In a priority queue, you don't normally want to visit all elements because the pattern of accessing a priority queue because you pull them out one at a time and you get them in priority order. But a set would be another example. But I'll give you another example that's a little bit more off the beaten track. A file, right? A file. You may want to read the characters in a file, and it is a file, right? And a file contains characters. Clients want to have the characters, and you don't have any idea what a file looks like. So you want to get some API to it, and you want to have multiple clients that should be able to read the file at the same time. And actually, if you use a scanner is kind of like an iterator. So whenever you have this context, the iterator pattern offers you a solution. It says, define an iterator that fetches one element at a time. That's what an iterator does. Each iterator object keeps track of the position of the next element in some way. Like in a linked list, it would hold the pointer to the next element. If you have an iterator through a hash table, it needs to know where it is in which bucket. And this one here, I've taken from the patterns book, where it says if there are several aggregate iterator variations, it's best if the aggregate iterator classes realize the common interface types. I don't even know today, standing right here, what the heck that is. So we're not going to talk about it. They must have had some use case in mind, and I only took that because that's what the demigods said. All right, so with all of these patterns come one of these UML diagrams, and they're also kind of abstract. So, now I know what the interface thing is. So we have a client that wants to visit an aggregate, meaning the linked list. There's a method called createIterator that the client calls. And once the client has the iterator, which is an object here, then it calls next is done current item. That's how I call these methods. So next it gives the next one, is done is, it tells you whether you're done with the iteration. And current item, I'll come to in a minute. So, and what the third line says is you want to have the aggregate and the iterator as interfaces so that you can have multiple implementations. And that's something that we do in the Java library, right? You have an abstract class list or interface list, you have an interface iterator, and then you have a concrete class linked list. And that way one can change the implementation. In fact, in Java, you also have a concrete class array list that also implements the list interface. So you have multiple implementations. And then, of course, you have different iterators, just kind of like you've done in the homework with the sequences, where there were different sequences. So, like I said, the names in the pattern are always examples, and it greatly helps to have a concrete realization of the pattern in mind. So, in particular, the create iterator in the pattern is actually list iterator. When you use linked lists, next is next, as it happens, is done, well, it's called has next for the linked list. But conceptually, if you have one, you have the other. And the current item method, it's kind of nice if an iterator lets you look up the current item without advancing the iterator. That way, sometimes it's just nice to be able to look at an item before consuming it. It's a good thing to have that choice. It's actually, it's the principle of least side effect. Right now, with a list iterator, if you want to look at the next element in a list, you can only do it with the side effect of also consuming it and advancing to the next one. But it would be nicer if there was like a get or occurrence. And so that's what the pattern says that's the best way to do it. The linked list iterator does not follow that part of the pattern. And one could say, maybe that's not so good. And in fact, I think that's not so good. I would have, every once in a while, I wish that they would have read that patterns book better and followed it more precisely, because those patterns guys know what they do. All right, another well-known design pattern that's quite complex, and we're not going to get into it in all of its complexity today, is what's called the model view controller panel. And so let me give you as an example of that something that maybe these days you no longer ever see. In fact, I had a hard time getting a modern incarnation of it. So there was a time when it was considered a good idea to provide editors for things like HTML, where you have both the what you see is what you get view and a structural view, and maybe even a third view, the raw text view. And you would be able to see them side by side. Maybe HTML is complex. I guess not. These days you can get some like HTML editors that still do the same thing, that show you the. Well, I guess what's become rare is to have a structural view. So I've seen quite a few editors where you have the actual HTML and then you have the raw text. But the structural view is something that people have not really felt very comfortable with. But for a while, people tried to make it possible for you to edit the structure in the separate interface. But so for right now, and that's how I'm going to change the screenshot in the next edition. Let's think of HTML text. Now, what happens when you update the text? Well, you would then expect to have the HTML view automatically update itself. What happens if you update the HTML in a WYSIWYG fashion? Then you expect that the text automatically tracks that. So you want both of those views always to be correct. How do you do that? So it doesn't seem like an easy matter, because if you have commands here to change fonts or something, then something has to happen over there in the other view, in the text view. And conversely, whatever edit you have here, you also have to simultaneously update that view. And that would be really hard to implement. Let's see if I have a picture here. Yes, I do. So the way these things are implemented is by an architecture called model view controller. And that's so generally useful that it's really very wonderful. And so whenever you have something where you have multiple visual representations of the same thing, here's what you're supposed to do, according to the patterns people. You're supposed to come up with the data that describe what's going on unambiguously, but without any visual anything. So in the case of an HTML editor, that might be the DOM tree. So that would be a data structure that is convenient for manipulation, but that by itself has no visual representation. Then for each of the visual representations, you design a view. So you would have an HTML view that actually renders the DOM tree with all the CSS attached and whatever. And then you have another visual that just shows it in text with a begin and end text. So you would have now two different views of the same model. And so they both look at the model. And that's in fact why the model is called a model. You should think of the model as being a model in an artist's studio. So this one here draws it with oil paint, and this one draws it in a cubist way, or whatever their art style is. So the model is the actual reality, the person that is being drawn, and there's more than one way to draw. So that's where the name model comes from. You don't think of it as like it's a model train or anything. That has nothing to do with it. So then there are controllers that I'm not going to say too much about that deal with the user interaction. So a controller would capture mouse clicks and keystrokes on these various views. So the idea is that the view itself should not have to worry about how it could be manipulated. That's complicated enough to put that into a separate class. Yeah?
Can we understand the model as data?
Yeah, the model is The pure data structure.
Yes.
No visual representation. Right, so that's like in the case of HTML, the DOM tree.
But should we? I mean, should the views directly use model or through
Yeah.
the controller?
No, the views directly query the model. So that each view will query the model about its structure and then draw it in the way that's appropriate. Okay, I'll give you another potentially useful way of thinking about the view of the model in a different example. Yeah. So, think of a stopwatch. There's a stopwatch at the back of your mind all the time. There's a view of a stopwatch. Right, that's a view of a stopwatch. There's another view of a stopwatch. Right, here's a different view of a stopwatch. A digital stopwatch. What's the model? Yeah, so the elapsed time. Yeah, something like 7702150. Right, that's the elapsed time in milliseconds. That's the model. Like the model is the pure data, no visual representation at all. And then there's multiple ways of visualizing. Okay, well that's a good timely example. So, the controller is the one that deals with the user interface. So let's say that the cursor is somewhere in one of the views and the user hits the X key. Then the controller might say, okay, that means it's a text insertion. It's going to make a method call on a model object called insert text, say, if that's what the model is. In this case, the model is going to tell all of the views that view it, hey, I've changed. Remember in the picture that I just had, the model had two views. It's going to tell the view 1, hey, I've changed. And it's going to tell the view number 2, hey, I've changed. And now the views will do what they always do. They will say, looks like I have to paint the model. The view knows how to go to the model a step at a time and paint everything. And so that way it's not terribly complex. If you need to write a program like that that can present multiple views, you already have to implement how the view paints a model. That's just the fact of life. And if you have multiple views, then each of them just continuously repaints itself. Now you might say that is horribly, horribly inefficient. And that might be. So in a practical implementation of a word processor, one would probably give some extra hints to the view and say, I've changed myself in the third paragraph or some such thing. And then some optimization can happen. But in the case of a user interface that fits on a single screen, they just repaint themselves all the time. So the kinds of user interfaces that you will be implementing in this class, you can simply say that the notification says, in whatever you thought I looked like is no longer true. I now look different, repaint me. And that way you can have multiple views that automatically track the changes. So a view doesn't even know whether the change came in through editing itself or through editing some other view. All it knows is to periodically repaint. So that's a clever way of doing this. And it's not an obvious way because there have been many attempts to write these kind of systems where each view tried to update all the others whenever some change was in the thought that, how hard can this be? But it does get pretty hard eventually. And so this is a faster, easier way to do it. Yeah?
So
Okay, that's a good question. So what she's asking is, does the model have a view, or does a view have a model?
I mean, here if we implement observer's pattern, so probably the view will observe the model for change.
So clearly, the view has to have a model because that's what it's viewing, right? That's what it needs to paint. Does a model have to have views? Yes, because it has to be able to tell all of its views. Hey, I've changed.
But,
So the model definitely has a list of views. That's the only way it can work because there's one point when it has to be able to tell them all.
but we can use observer's
Well, but that's what the observer pattern says, is that the thing that's being observed has a list of the observers.
pattern.
All right, so let's get to the observer pattern.
But can we go back?
Yep.
So for the controller here.
Yeah.
So actually insert text. This function is called by view, right?
No, the view has no conception of editing. That's an important part. So a view is not editable. A view simply looks at the model and redraws
So
it.
text view is a view, but like text edit is not. Right?
So this is in the context of some text processing system, like Microsoft Word.
Okay.
And so there, the model, which is the actual documents, which is paragraphs and whatever. Think of HTML.
Right.
The model, there has to be a method to insert text at a cursor position. But a view has no conception of inserting text.
Yeah, but who calls the insert text?
The controller. That's how the controller represents the user interface. The controller deals with the fact that some user hit a key, X, hit the X key. And now what's to do with the X key? The controller then calls the model and say, hey model, one wants to change you by inserting the letter X at this cursor position. So, conversely, the controller has no idea that there is such a thing as a view, really. In practice, that's not quite true because the cursor has to be somewhere in the view, but let's not get into that. The controller is the hardest part to get right, and so I want to get rid of the controller right now because it is complicated and we don't need it in a lot of cases. And the design pattern that's in the Gang of Four Patterns book does distills out that simplest of patterns that deals with how the model and the view are related to each other. So the model notifies the views when something interesting happens. And as the example here, I'm using action listeners and buttons. So we've talked about buttons. You're implementing a button. So the button here my button that says what button are we going to install? And now someone clicks the start button, and who gets notified? Yeah, some action listener, that Lambda thing that says. Can you have more than one action listener attached to a button? Yeah, you can have as many as you like. It's not super common, but it does happen. In fact, I recently had a case when I needed to do that, and in JavaFX you can't do it, and it's a pain. So you can have as many of these action listeners as you like. They don't have to be Lambda expressions, but let's say that, right? So, in this case, the pattern of behavior is very similar to what we've seen before. That when this button gets clicked, it tells this guy, hey, something's happening. Hey, something is happening. It's not super much the same, right? These action listeners, they don't view the button. give a visual representation. But what's still the same is the communication pattern, that the listeners want to know when something is happening with a button. The views want to know when something is happening with a model. And that wanting to know is what the observer pattern tries to do. So here's the pattern. It says that we have a source of events, and we call that the subject. The subject would be the model in model view, or would be a button when you have button and listeners. And one or more observer objects want to be notified when some event occurs. Those observer objects would be the views in model view, or they would be the listeners with the buttons. And it says now define an observer interface type, like action listener. And the concrete observers implement it. The subject maintains a collection of observers. That's what I just said, that the subject, like the model, needs to know whom to notify. It needs to keep a list of everyone who's interested. So when you call add action listener on a button, the button actually has a list of action listeners inside itself, and it gets added to. The subject supplies methods for attaching and detaching observers. Add action listener. There's actually a remove action listener as well. No, it's not super often used, but it is there because they're following the pattern. So here you can see that the subject has a bunch of observers. That it has a method attached that allows an observer to attach itself, and the observer has a method for notifying that allows it to be notified. And here we have it again. In the case of the button, where the subject is a J button, the observer is an action listener, attach is add action listener, and notify is action performed. You don't normally think about action performed anymore because we are in the wonderful world of lambdas, where whatever that single method was called, that's what the lambda body does. Yeah?
If both the view and model have each other, wouldn't that be a bad design? Because this is a loop there.
It's like you can't say it's always bad to have these circular dependencies. In the case of buttons and handlers, that probably there's no particular need to write that the handler doesn't really do anything to the button anymore. But if let's see if I can think of like with lists. I think in those user interface cases, but with model view, that's just the way it is. And so you can't blanket say, this is it's always bad to have circular. All right, that's all that I have here. On Thursday, unfortunately, I won't be here. I have to go to the dentist to get a root canal. The only time that I got. And so I will give you some reading and a sample test with some sample questions that imitate what you might see on the midterm. The midterm is next Tuesday, right? That's what the schedule says. Let's double check. But unless, well, it has to be sometime. I can have it on Thursday if you all want the midterm on Thursday. Usually these things don't go over so well. So no, it's next Tuesday. There's no homework for Wednesday, so that you have time to practice for the midterm. So I will give you some study guide and some sample questions. On the midterm, it is essential that everyone knows how to make a directory in your GitHub directory, put your midterm work in there, and check it into GitHub. That's the only way that I will take the homework. Okay, so make sure that you can do that in real time. And then you just have to run commit every 10 minutes or so. That A, you don't lose your work, and B, I know that's all yours. Yes?
Do we have to have descriptive commit messages for the example?
No, you can just say X or something. And generally, I don't really. I mean, it's good habit to have good commit messages, but I'm not always, as you can see from mine, not always very good. So you don't have to do it. Also, in the exam, you do not have to put in comments unless I specifically ask you. So if there's some code that needs to be written, because that's such constrained time. I will always give you starter code because I know from experience that it's difficult for students to write code as quickly as one would like. So you should expect to fill in, 3 or 4 lines of code somewhere, and not like a page. So if it looks excessive, then you're probably not doing it the way that I was thinking about it. So there'll be 4 or 5 questions, and each of them has a few lines of code. That's all that I can expect at the time. There'll be some question where I say, what's wrong about this, or why is this so, where I want to have some verbal explanations. Try to make those as crisp as possible. I'll give you a reading list that you can follow, which parts of the book I think are most important. The one thing for sure is most questions will have something to do with the prior homeworks. So make sure that you're familiar with both your and my solutions. So the best thing you can in fact do is look at my solutions and see where they're different, better or worse than yours. That way you automatically review both yours. Tuesday, next Tuesday. Nice try, next Tuesday. I'm not changing it, okay? Next Tuesday is the exam, okay? This Thursday, I will not be here. You can all feel for me while I'm at the dentist chair. Yes, all right?
Yeah.
Sorry?
Yes.